So we'll do this example next. Do you have any questions? Of course, questions might slow me down on doing this problem. Any ideas why we shouldn't do this problem? Well, but we're not going to do it this way you think we're going to do it. Okay, so what we're going to do it is we're going to use WX maxima here. And one of the problems on the homework assignment, also I do this, what you do is here in WX maxima, you go to enter matrix, and you can do 4, you can give it a name. There, and then you have to enter, then we're going to do, this makes entering the matrix easy. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and there we have the matrix. Now, the first thing we're supposed to do is find the characteristic equation, right, or characteristic polynomial. Well, if we go to algebra, there's actually an item, characteristic polynomial. And we have to choose what it is. And we're going to choose the matrix is M, and we can just choose X for the variable. Okay, so there it is. X to the 4th minus 4x cubed, right? So that there, and so we can give this, I think, a well, we can give this a, let's see if this will work. There. Then if I type P, that gives that, and I can then factor P. Oh, it's easy to do. I can see then I've got 4 minus X, so the eigenvalues are a triple root X and the thing 4, right? So everybody's repeated root things. So it's probably good to then just go and I can choose eigenvalues and eigenvectors. So if I choose eigenvalues, then I since it's percent, I have to sometimes go in WX maxing, you can put things in like this, and there you get that. The that doesn't tell you anything extra. So what we're doing, just to review, what we're doing is we put in the big 4x4 matrix, all 1 entries here, and then in this entry is a characteristic. You can find the characteristic polynomial, which is this, and you can factor it, and you can see that, oh yeah, look, there's repeated roots. Eigenvalue doesn't tell you much. Just to understand notation, see, this is the eigenvalue 0, right? This 3 tells you its multiplicity. That means the root, this 0 counts for 3 times, 3 factors. And the 4 accounts for 1. So this doesn't really tell us anything new except for the notation. But then we come here and do eigenvectors. We have to, again, you can redo cells in WX maxima, so we put M in. And then we get somewhere interesting. So it repeats the eigenvalue thing up here. This is a list of lists, right? But you can sort of see that there's the 2 pieces here, right? Which are just repeating this. But the second list repeats the eigenvectors, right? And it gives you the eigenvectors. And they're giving you them in the same order they appeared up here. So these first 3 are, so we have here, to read them off, we have here lambda 1 equals 0 with V1 equals 1, 0, 0, minus 1, right? And lambda 2 equals 0 with V2 equals 0, 1, 0, minus 1. and lambda 3 equals 0 with V3 equals 0, 0, 1, minus 1, and lambda 4 is 4 with V4 equaling 1, 1, 1, 1. And you can see, if you just imagine multiplying this matrix times each of these four eigenvectors. If I do 1, 1, 1 here, each row I'm going to get 1 plus 1 plus 1 plus 1, which will be 4, 4, 4, 4. So I factor out the 4 times 1, 1, 1, 1. On the other hand, these ones, each one corresponds to like a 2 zeros and a 1 and a minus 1. So if I go through and I multiply this out, there's going to be this row times this one is going to end up being 1 plus minus 1 is 0. In each row, it's going to be 1 plus minus 1 is 0. So I'm going to get 0 times the vector back. So it works. The point is that on the assignment, let's look at the assignment that here on the RigX assignment. Usually I have you write everything out by hand. So I want you to write out, like on this assignment, let's look at the last problem. Here's what are the eigenvectors and eigenvalues of this matrix here? Okay. So what you want to do is you'll want to find the characteristic polynomial and the equation, and you'll find it with Wx max, but still write it out. Say, okay, here's the characteristic polynomial with the characteristic equation. You can factor it, and it will factor, and where the eigenvalues will not be 0, it won't have any repeated roots. And then you can just, then you have to have 4 linear systems to solve with 4x4, 4x4 system. I want you to do the first one explicitly, and then you can use the others if you wish. You can do them all explicitly, or you can come up here and solve them as under equations. You have solved linear system. So you can put the other 3 linear systems in to Wx maximal. Put the say second one in, edit it, make it, solve it, and then it's going to give you. Now it will. You have to sort of maybe we should do that with something so you sort of see what happens, because anyway, you have to play around with it to understand, because it has a certain convention for how it writes if you solve a linear system with 3 variables. So you don't want to not leave that one to the last one. Okay, well, so and there's other, this one is sort of the one that you have available on Vera Virtual if you have that. And Wx Maximum is free and installable on Windows Macs. Sometimes people have trouble with that. And there's lots of other online linear algebra tools that you could probably do the same thing with, so that if you can probably look and find there's lots of like online linear algebra tools that you put in matrices, but you might not have one that gives you you want to find one that gives you the characteristic polynomial, and that you can then do, so you can lay it out as if you did all the calculations, so that you can see, okay, here's the characteristic polynomial, here's the factored form of the polynomial, here is so the eigenvalues are such and such. So you can go through the process, but instead of doing the algebra by hand, now in the other cases, like for example, with the other cases, I'm asking you to do it by hand and write out like the form of how you do it with a 2x2 or 3x3 matrix, so that you actually have to display you always check your results with Wx max to make sure you're getting the right answer, but then you can you have to write in Wix the derivation, so you show that even if you read an answer beforehand, that you've actually gone through the motions of solving it. Okay. Well, that is the story